Hi guys, so in this video we will go in through the calculation DC AC and DC distribution calculation, right? So my plan is to cover ring and interconnected for this video. However, that's gonna depend on the length of the video. If the video gets to be too long, then I'm only gonna cover ring, and then if I feel like okay I can couple it with interconnected, I will do so. But I think it will only be ideal if I make like 4 separate videos, because we have DC ring, we have DC interconnected, AC ring, and then AC interconnected. So I think it will be good if I have like 4 separate videos, so that each person goes straight to whatever that they struggle with, right? So we'll see how it turns out. So please copy this thing somewhere, just have it somewhere. This is gonna be our what you call that, our mind map, right? I'm gonna do these calculations following these steps. So yeah, without wasting any time, let's get to our calculations. So I, I'm using our ETG notes, our ETG slides, right? And I'm now on slide 10, example 1, slide number 10. I'm just gonna read the question and then take down some data, and then yeah, we're good to go. So it reads like this: a 2-wire ring distributor is 880 meters long and is fed at point A with a voltage of 480 volts. Loads of 74 amps, 96 amps, and 82 amps are tapped from the distributor at point B, C, and D respectively. The resistance of a single conductor is 0.42 ohms per kilometer of distributor cable. The highlight the single, meaning each wire has 0.42 ohms per kilometer. Now it's a DC, meaning we have 2 wires. Remember, DC is 2 wires. We have neutral and then we have live, right? Good. So what I'm gonna do, meaning now the first thing that you're gonna do, I don't know what you're gonna call this value, this 0.42. Just call it whatever that makes you sleep good at night. I'm just gonna call it the resistance coefficient, or maybe R per distance. Yeah, I think R per D, that's good. 0.42 ohms per kilometer. Now, when you're gonna need the distance of each distributor, right? So from D, A, B, that's distance from A to B is equals to 120 meters, and then distance from B to C, that is 300 meters, and then distance from C to D is equals to 220 meters, and lastly distance from D to A is equals to 240 meters, right? Cool. So to calculate the resistance of each distributor now, let's say distribute from A to B, let's call it AB. Resistance AB is equals to the distance times the resistance per distance. I don't know how to, again, it depends on how you understand it, but we're gonna do the same thing. We're gonna take the distance of AB, that's 120. Oh, is in meters. We're gonna convert it to kilometers. We divide by 1000 is 0.12 times 0.42. Now remember something, we said it's 2y, I mean you're gonna multiply this by 2 and multiply this by 2, right? So the resistance AB is gonna be 0.4, no, 42 times 0.12 times 2. This is 0.12. Please don't, I'm sorry, it's a mistake. Good. So it gives us 0.1008 ohms, right? Resistance BC is equals to distance times R per distance times 2 again. Now our distance is 3 ohms, that's 0.3 times 0.42 times 2. The answer is 0.42 times 0.3 times 2. That's 0.252 ohms. Then we have RCD is equals to, again, distance R per D times 2. So that is 0.22 times 0.42 times 2. and the answer should be 0,1848. Then we have RDA is equals to again D R per D times 2. That is 0,24 times 0,42 times 2, and the answer should be 0,2016 ohms, right? So I hope you have your resistance down. I'm gonna remove this for space, right? Cool. So I'm gonna take everything down, delete, and then delete. Come on, why are you still there? Okay. So now I'm gonna draw our system. We have this, something like this. Let's say this is distributor A. I mean the bus bar A. Nah, we have something like this. That's B. Let's see. And we have D there. You have something like this. Nah? Now, out of, let's start with B. Out of B, you have, I think it's 0, I mean, it's, it's 74, I'm sorry, 74 amps. And then this is 82, 96, what is it? It's 96. 96 amps. And then out of D, you have 82 coming out. This is your load currents, 82 amps. Good. You have something like this. And then your supplier is 48 volts. It's very important to remember that. Good. So we know that the resistance from this point to this point is 0,252 ohms, and then the resistance from B to C, how much was it? What was it? Hey, how do I forget that? No, I removed it. Oh, this is 0, I'm sorry, this is 0,252. Hi man. And then this right here is actually 0,1008. I'm sorry. And now from C to D you have 0,1848, and then from D to A you have 0,2016 ohms. Cool. So yeah, we're good. So I'm gonna pause the video and then just put this thing where it should be. Let me pause the video. Good. So now the first thing that we need to do, it says here on the mind map, I'm not gonna go back to it. Okay, I'm just gonna go back to it for the last time. This is what we have, right? We're gonna find the resistance of which has did, meaning this first step is gone. Sometimes they're gonna give you the resistance. I mean, it's not all the time that they're gonna give you a distance and expect you to calculate resistance. That's too easy. They going to test you on real stuff, right? Sharp. And then what we're going to do now, we're going to apply Kirchhoff's law to find the distributor currents. That's what you're going to do. After that, we're going to express each current with AB, meaning in terms of AB. Good. Then you're going to apply again Kirchhoff's law, this time Kirchhoff's voltage law, to find the volts or the volt drop per each distributor. So let's go. That was the last time viewing that page, so please just have it copied somewhere. All right. Cool. So now we have to apply Kirchhoff's current law. Good. Now I'm not sure if you still remember, but you remember when we have something like this. Let's say this is a point. This is point B, right? You have current. Let's call it AB. Current AB coming into point B, and then you have IB coming out of the point. Oh, not BC. IB. Then we have now current BC again leaving the point. You know that Kirchhoff's current law says that this current right here, which is AB, is equals to this plus that, right? So that's what we're gonna apply now. Whoa, I'm really sorry about that. I'm new to this thing. I don't know, I think I pressed paste instead of delete. Okay, now I look unprofessional now. It's okay. So that's what we're gonna do. Right now, current at bus bar B is gonna be, actually, you see you have IAB. I forgot my hours. Let me change the color. Come on. You have IAB coming into the thingy, the bus bar, and then BC leaving the bus bar, entering bus bar C, right? Current CD entering bus bar D, and then current DA entering bus bar A. Cool. So meaning our first equation is IAB is equals to IC plus IBC. This is plus, ne? Yeah, that's plus. So now you have current AB as IBC plus 74. Let's call this equation 1. So now we're going to find BC, this one right here. Good. So BC, you see BC is leaving bus bar what is this, B, right? Meaning we're just gonna manipulate this formula, now make BC subject of the formula. IB no, AB, right? So meaning BC is equals to AB minus 74. That's equation 2. Good. Now okay, I'm gonna underline it as well. Now we have to find current DC, right? Current DC is the sum of this plus that, because it is entering bus bar D, and the same current, which is current DC, is also this minus that. Let me show you. Yeah, IBC is equals to IC plus IDC. Is it, there is your point. BC is entering, and then C is leaving, and then CD is also leaving, right? That is why I said IBC is equals to IC plus IDC, right? Now I'm gonna manipulate the formula, just make DC substitute of the formula, and substitute the value of IC, meaning IDC is equals to IBC minus 96. Good. That's now and the last one, that is DA. DA leaves bus bar D, and then D is also leaving bus bar D, meaning DA is just this minus that. I hope you get it. I know you do. IDA is equals to ICD minus ID, that is ICD minus 82. Let me check again, double check if I'm right. Okay, we will stack forward. Let's move. Yeah, let's move. Let me erase this thing. Let me erase this. Hey, oh, I knew it. Cool. So next point, on next stop on our mind map, it says now we express each current in terms of AB. We just want to have one unknown. You will see why is that, right? So AB is just AB. meaning we have AB is just AB, right? Now let's express BC. Current BC, we said here current BC is equal to AB minus 74, meaning BC is also in terms of A. Good. So it's AB minus 74. Now we have CD. CD is BC minus 96, meaning what we're gonna do is that we're gonna take this, because remember BC is equal to this expression here, meaning we have every right to substitute, which has in terms of saying BC, which has substitute this on DC. Okay, cool. So IDC is equal to IC plus no. Let me pause this. What's happening here? I'm gonna refresh what I just said now. I'm sorry. IBC is equal to AB minus 74, right? IDC is IBC minus 96. Meaning now we can substitute this expression, this one right here. We can substitute it there, here. That's what we're gonna do, right? Because we want it in terms of AB. Good. So our IDC is equal to, let me say again, it's IBC minus 96, meaning is this right here minus 96, right? Cool. So that's IBC minus 74. Now we have minus 96, and that should be 170 if I'm not mistaken. Yeah. So it's equals to IAB minus 120. That is your DC. So what I'm gonna do, because I want to create space, I'm gonna erase this, right? And then take this, put it up there. I'm gonna put it up here. Good. Now I left with one last current, that is DA. Yeah, our DA is ICD minus 82. Good. Our DA is this minus 82, meaning instead of saying DC, we're going to substitute IAB minus 120, and then we subtract 82 from that. Is IAB minus 120 minus 82. That should be IAB minus 252. Oh, my 5 is always giving me problems. Okay, let me just confirm. Plus 82. Good, we are good. So again, I'm gonna create space, remove this, delete everything, delete, and then take you, put you up there. That is IDA. Good. So we're done with step number, what step is that? Is step number 3. So our last step, we apply Kirchhoff's law now to find the voltage drop, right? Voltage, Kirchhoff's voltage law. So you know that sum of voltages around the loop result to 0, right? We're gonna do that. I'm gonna also change color, G for control. Let's go. So VAB plus VBC plus VCD plus VDA equals 0, right? Now we know that Ohm's law, VAB is simply IAB RAB plus VBC is IBC RBC plus ICD RCD plus IDA RDA is equal to 0. You know what I just did here? I didn't do any magic here, right? Cool. So I'm going to now substitute our currents with what we found here. Yeah. So current AB, current AB is just AB, and then BC is AB minus 74. Blah 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 blah. I'm gonna do that. IAB RAB plus, now you have your other current, then you have, what is this? This is now RBC plus your current RCD plus, oh, space your current. Let me make it a bit small. Gosh. Okay, now what was it? We were at RDC, meaning this is now RDA, all equals to 0. We have distributor 1, 2, 3, and 4. Cool. Now I'm just gonna copy all of these currents here, place them at the rightful places. We first start with BC. Copy, paste. First gonna make it a bit smaller and then put it in there. Good. That's BC, right? And then we have DC. We do the same thing. I wish I could pause a video, but I don't feel like it. Copy, paste, resize. Oh, I'm gonna resize it again so it fits the block. Okay, again. Good. And then we have the last current, that's DA. Again, select, oh no, select and then copy. We come here. This is a small bracket, isn't it? Very small. Yeah, I hope you see. I know you can. And then now multiply or break the brackets. So I'm gonna pause the video, break the brackets alone, and yeah, I'll come back with a good expression. Oh, the other thing, I'm gonna remove these currents here because now they actually showing a lot of space. Oh, yeah. Okay, let me do that off the video. So we have something like this, right? We have this. Breaking down the bracket led me to this expression here. Good. So again, I'm gonna break the brackets and now substitute the resistances now. For our RAB is 0,1008, and then we don't have AB plus, what is this? What's happening here? That should be IAB. My god. Oh no. Good. We only have the value of V of B of IAB. We have the value of the resistance RBC. RBC is 0,252 IAB. So I'm gonna do that and then again pause the video. I'm gonna pause the video, do that, and then play the video again. I'm sorry. So what I did now, remember last time I was here, right? Cool. So I did that and then I got this. From there, I just, you see the ones or the current or the values with as purple, this circle, whatever that I was doing, those are the AB terms, right? So I did them together, they gave me 0, oh no, they gave me 0.7392 AB. And then where I highlighted with gray, I got negative 100,8672 transpose divided by the coefficient of AB, and then I got 136,454 amps. So that's our value of AB now. So what we're gonna do now is to get the other currents. Yeah, remember we expressed all the currents with in terms of AB, so you're gonna get all those currents. Substituting the value of AB, which is 136, in this one, and then getting AB, getting other currents is that simple. I'm gonna do it off the video and then hope you follow through. So I substituted I substituted the value of AB that we just calculated down there, right, to find that 62 as BC, then minus 33,546 as DC, and then minus 115,546 amps as DA. Now the negative, I know you've been told it will make me feel good to say it too. Yeah, so I'm gonna say it. I'm sorry. The negative there, it's just to denote or to make us aware that we actually got the currents wrong, meaning instead of, well, what is that? It's DC and DA. Instead of having this arrow pointing or at bus bar D, the current is actually traveling or flowing in this direction. And then the same this side is traveling this direction as opposed to this direction. Good, I hope you see it. However, if you calculate your current, say you also calculate power or anything, please include that negative there. Meaning if you're gonna substitute negative 33 comma something, don't omit the negative sign. It's important, you have to include it too. So now I'm gonna calculate the voltage drop by each distributor. We know that, oh, I don't have space. Okay, what should I do? Let me copy all of this. Oh no, oh no, I'm gonna copy all of this, copy, and then paste them on the next page. Now we're gonna calculate voltage here, right? The voltage drop per each distributor. VAB, VAB is simply IAB times RAB, right? That's gonna be 136,454 times 0,008. I'm sorry, and that should give us, let's see, 136,454 times 0,108. That's 13,755 volts. We're gonna do the same. I'm gonna do the same for what is this? BC, CD, as well as DA of the video. So I'm gonna pause the video. So there you have it. I did all of this of the video, so otherwise I didn't do anything that you don't know. Just all of that, right? So now let's find our voltage, our load voltage, like VB. We know is gonna be applying a voltage, Kirchhoff voltage law is gonna be VA minus VAB, right? So that's 480 minus our VAB is 13,755. So 13,755, and the answer is 480 minus 13,755. The answer is 466,254 volts, right? And then we have VC. VC is equals to there's gonna be what is VC? What is VC? Voltage here. Looking at the arrows. I'm sorry, I'm distracted. Let me pause this. I'm sorry about that. VC is gonna be VB minus let me go, is VB minus VBC, right? So that's gonna be, we just calculate VB is 466 comma 254 minus, now you're gonna minus VBC, and VBC is 15,738 15,738. that is gonna be minus 15,738. That's 450,507 450,507 volts. And then we have, I think this is the last one, that's what is VC. VD of load voltage VD is equals to VC minus VDC. That's gonna be the answer that we just got. That is 450,507 minus, now we're going to look for DC. Where is VDC? I didn't calculate it. What happened here? As in, I don't know what I did there. I'm gonna say IDC RDC because I don't know what happened. So I'm gonna calculate it either way. That's 450,507. Guys, this video is taking too long. I'm exhausted. I'm bored. Quadrillium, all of these bad things. IDC was IDC. IDC is minus 33,546. Let's go. Minus 33,546. Now you're gonna multiply it with, I think, DC, what is it? Oh, there it is. Oh god. This video is taking too long now. I didn't think I was gonna take this long. Doing just a simple example. What is it? It's negative 6.2. So 45, and then we add 6.2. Now we have 456,707 volts. So there you have it. That's your first example. I lost my mood now. I'm tired. Yeah.